Guys, welcome back again. We are about to start lesson 9 of unit 2, day 1. Let's get started. So you're going to need your lesson book. We're going to be on page 74 and 75. Also get a notebook and something to write with, okay? Today we're going to be able to understand that the rate of change is also your slope of the line. So we've talked about rate of change. We've compared rate of change, and now we're going to look at a graph and tables, and we're going to talk about how that's going to become our slope. That's what we're doing in lesson 9. So let's look at what we have here. We're going to make sense of this problem. So in your notebook, I want you to write down anything you see that's important. What are we trying to find out from the problem that I read? Okay, so let's get started. Wilson Middle School has money left over from last year's fundraiser. This year's students are selling discount cards for local businesses. The graph shows the leftover money and the amount the school will earn for each card sold. Write an equation that shows the total amount of money the school will have, including leftover money, and the amount earned selling X number of cards. So this actually doesn't seem different from kind of some of the stuff that we've done, some of the stuff you've seen in 7th grade. So I'm going to read it again. Okay, so the first time you listened, second time, again, write things down. And if you need to pause my video to write things down too, you are more than welcome to, okay? So I'm going to read it a second time. Wilson Middle School has money left over from last year's fundraiser. This year, the students are selling discount cards for local businesses. The graph shows leftover money and the amount the school will earn for each card sold. Write an equation that shows the total amount of money the school will have, including the leftover money and the amount of money earned selling X number of cards. So at this time, I want you to pause my video. That way, you have time to write down as many things as you can. Okay, pause. All right, did I give you enough time? Did you pause it and write down what you could come up with? So again, the reason why we're doing this is because in order to find out the answer to the problem and to be able to make sure our answer makes sense is to write down and circle and highlight and do what you do in English, math, in English, science, and social studies where you annotate. We want to make sure you're annotating the important information before you answer the question. That way we actually make sense of what we need and why we need it. Okay, so let's see if yours match mine. So Wilson Middle School has money left over from last year's fundraiser. This year, the students are selling discounts cards. So the graph, I know what's behind this box. I bet it's a graph. Shows leftover money and the amount the school will earn for each card. Do I know how much money each card is? Nope. Do I know how much leftover money? Nope. But the second part, and this is actually our point of this, we want to write an equation that shows the total amount of money the school will have, including the leftover money and the amount of money. There's a lot we have here. Okay, so let's see what we have. We want to write an equation. So we're going to come over here. I have to have an equation. And in my equation, I want the total amount of money that includes the leftover money and the amount of, so I have to have the leftover money and the amount of money earned selling X number of cards. Do we know an equation that's going to help us out with this before we even pull out these numbers? Think about one that you've had to write in your notebook from lesson 7, and we used it in lesson 8. I'll give you a hint. Starts with a Y equals. Okay, did you say mx plus b? Oh, okay. So we're actually probably going to use this. Now, let me go ahead and move my little equation up here. Okay. Let's go ahead and move this. All right, so what I want you to do now is I want you to pause my video, and you are going to write an equation from the information that you have here, okay? So pause my video and write an equation that shows the total amount of money the school will have, including leftover money, and the amount earned selling X number of cards. Pause. 3, 2, 1. Let's see what we got here. Okay, so I'm going to erase some of our trick words, our clue words. I didn't want to do that. And let me move you back here. Okay, so let's see how you did. I'm going to go to another screen so I can make it bigger. And let's enlarge this so we can break it down, okay? All right. So a few things. We know that we're looking at y equals m times x plus b. Okay, we know that this m is our rate of change. And what is this b? Remember what that b was called? Yeah, that b was called our initial value. Okay. So if we don't know anything about this graph, and if we just look at our word problem, let's pull this guy over. Can we figure out what number is going to be our initial value? Did you say leftover money? Our leftover money is going to be our initial value. And then what's going to be our rate of change? The amount of money for each card. So here's our rate of change is what we're going to make from each card, and our initial value is our leftover money. Okay, so now let's look at our graph. Boop, boop, bring it over. There we go. Okay. So let's look at what we have. How much did they start with before we started selling? Good. Did you say $100? Because it's right on that 100, right? So my initial value is going to be $100. Now let's talk about how we find the rate of change. Remember, my rate of change is rise over run. Okay, we went over that, and y'all been practicing that, right? Rise. So we're going to go rise from 100 to 120 is 20. And then what happens when we go over? Y over x, so our y is 20, our x is, be very careful, we look down here, okay? I bet you thought it might be 20, huh? A lot of my students said 20. So if they said 20, what are we forgetting to do? We see that it's 20 this way, but did we look down here and make sure we did our run? Because if we did the rise, we still have to do over run. We still have to make sure we do it over x. So 5, 10, that would be 10. Otherwise, each card would be worth $20. But in this case, 20 divided by 10, that won't be 20. That's going to be 2. And what's that 2 going to represent? I might have to go back just to make sure. Let's see, that 2, what is it gonna be? The amount the school will earn for each card sold. So for each card sold, the school is going to make $2. Good. Okay, so now let's go ahead and plug it into our equation. So we have y equals mx plus b, where our m is our rate of change, our b is our initial value. Now we just get to plug it in. So I'm going to give you a chance. Go ahead and plug it in and see if you can rewrite it, and I'll wait. Pause. Okay, so let's see if you plugged it in right. Did you put that 2 right here and that 100 right here? So you're left with y equals 2x plus 100? I hope you did, because you'd be right. Good job. Okay, so what we just went over and what we're reviewing is our rise over run. So in your notebooks, I want you to pause this because you're going to take a few little notes. Yes, you've wrote it already, but you're going to need this for the rest of this unit, and you'll also be using it in our first lesson of Unit 3. So I want to make sure you have it down. So you're going to pause my video and write the rise of vertical change over the run of your horizontal change. Remember, your vertical change goes up and down. Your horizontal change goes side to side. And in turn, this equals y over x. Pause my video so you can get this down in your notebook. 3, 2, and 1. Okay, so now keep your notebooks open because we're going to add to it, okay? So we're still talking about our m, our rate of change. And we're also talking about that rise over run also means the difference. And again, we've written this before as well, but we're going to write it again because we want to make sure the difference of x of the difference of y is our rate of change. But guess what we're going to start calling it today? We're going to start calling it the slope of our line, okay? And in turn, I'm going to give you an equation. So we have y, oh, did anybody catch this? Could anybody see? The y should be on top, and my x should be on bottom. I really hope you did, because I'm trying to see if y'all can make sure we know y's over x, okay? So if you didn't catch it, maybe I'll get you next time. But I want to make sure we know that y goes over x, y over x, y over x, y over x. Say it as many times as you need to, because if you do x over y, it's going to be upside down, and you're not going to have it right. It's going to be backwards. So, and that m right here is what I'm multiplying by. It's my slope, my rate of change, and we're connecting all of it today. That's what we're doing, okay? So make sure you write this equation, y2 minus y1 over x2 minus x1, because we're going to use that today, and we're going to use it in day 2 as well, okay? Pause my video. Okay, did you get everything down? You wrote it down, and it's all pretty in your notebook with color, or maybe you're just like pencil. That's fine too. I like color. Okay, so let's look at these 3 graphs. We're going to talk about the slope of these graphs, okay? So what I want you to do first, I want you to pause my video. Of course, this last one is graph C. I want you to pause my video. When I say pause, you're going to find your slope of graph A, graph B, and graph C. And then try to see if you can write 3 sentences describing your graphs, okay? And that's what we're also going to do together. But I want you to have time to do it on your own before we do it, before we go over it. So pause my video, find the slopes of your graphs. Go, pause. 3, 2, 1. I asked you to do a lot just now, didn't I? I sure did. So I asked you to find the graphs, find the slope of my 3 graphs, and I also wanted you to write 3 sentences describing my graphs. So it's important if we can already describe our graphs. Oh my goodness, like y'all totally know it really well. So the most important part of doing this graph finding and slope, which is the same thing as rate of change, find out where your crosshairs are or where your ordered pairs are, where we're meeting up, okay? So if I look at graph A, I'm meeting up right here, okay? And I'm going to go ahead and draw a little triangle. That's going to help us with lesson 12. You'll see soon. But I'm going to make me a little right triangle here, so it'll help me with my rise over run. Okay, up and over. So I'm going up, rise. Look, I'm going to do it like this. I'm going to write a y over x. Up, how many? 1. And we're going to go over 2. What's my slope? 1/2. Good. Okay, let's look at the slope because I can't describe my slopes yet until I have all my slopes, right? Okay, let's do graph B. And I'm going to do my little points. Oh my goodness, look. There's a whole lot of points on this one. So let's talk about my y over my x. How many do I go up? Good. I'm going to rise 1, y first. And then how many am I going over? Yep, I go over 1. So let's simplify that. So 1 over 1 is just 1. Good. Finally, let's do this other one. So we have up and over, rise, over, run. So I'm going to go put the little point here, point here, point here. Now I have two ordered pairs. I might go ahead and plug in that equation. So let's see if I could do that equation. So y2 minus y1 over x2 minus x1. So here's my x2, y2. Here's my x1, y1. So if I did x2, that would be 4, minus y1 would be 2, over x2 would be 2, x1 would be 1. I'm left with 2 over 1. Now let's simplify 2 over 1. What is happening here? There we go. 2 over 1 is going to simplify 2. Good job, 2. Okay, so let's talk about some sentences here. Write 3 sentences describing these 3 graphs. So what's one sentence you can tell me? Could you tell me that maybe graph C has a greater slope than graph A? Okay. What about, and look, you can even say how much greater, right? We have 1/2 versus 2. Okay. What else could you tell me? Are any of them negative? Okay, so all 3 graphs are positive because they're all going to the upper right. Okay, so they're all positive graphs. What's something else you can tell me? How about all my graphs start on 0, 0? So you could even tell me that they're all, do you remember that word from 7th grade? It starts with a P. They're all proportional. Oh, that's a good one. That's going to be, actually, we're going to get to proportional relationships in Unit 3, so we'll get there soon. Good job, guys. So this is slope. It feels exactly like rate of change, because it is. It's exactly rate of change. Okay, so we're going to end with this. What number will the x-coordinate always be in the ordered pair that identifies the y-intercept? I know we've talked about this, but that's a good question to end on. I bet if we went back to here, and if I pulled this down, where we have our y-intercept, did we talk about our y-intercept? Let's talk about that. So this guy right here, he's our initial value, isn't he? What axis is he on? He's on our y-axis, isn't he? He sure is. This is through the y-axis. So if I said he intersects through the y, where does he go through? He goes through at 100. So to help us answer our reflect question, I want you to think about what this ordered pair will be. And then we'll see if that works for any of them. So your question states, what ordered pair does your y-intercept have to be in order to be your y-intercept? So your x has to be something. What does my x have to be a y-intercept? So pause my video and see if you could write down this ordered pair right here. Pause. Let's see how you did. So this ordered pair, my x doesn't move, so my x is 0, and my y is 100. Was that our y-intercept in our y equals mx plus b? It was, wasn't it? What do you notice about your x value? It's 0, isn't it? Your x is 0, and your y is exactly where it went through the y. So let's go back to our reflection, and I wonder if that happens every time. So our reflect was, what number will the x-coordinate be in an ordered pair that defines the y-intercept? So it worked with our 100, right? Here's our x, y. I want to know, does it work with all of them, and how do you know? Pause my video and see if you can figure it out. 3, 2, 1. Let's see how you did. So did you say your x always has to be 0? Because in order to be a y-intercept and go through your y-axis, that your x has to be 0 every single time. That's what it is. Good job today, guys. You did great. So see me next time, and we'll do day 2. Okay? Bye.